then given this equation at the top, and we are expected to write the unsimplified version of it as a logic circuit. So we're going to start with the x plus y prime prime. So in order to do that, we want to take this x and this y. This y, we're actually going to pass through a NOT gate in order to convert it to y prime. And then these two values are going to come together into a NOR gate. And that is going to give us the first part of the equation. And now we're going to move on to the second part, which is going to be z prime. So once again, z is going to go through a NOR gate, or a NOT gate, my apologies. And then it is also going to go through an AND gate with x prime plus y. But in order to do that, we're going to start by creating another OR gate in order to get that. So x is going to come down here. We're going to pass this through another NOT gate in order to get x prime. Y, before it goes through the NOT gate, we're going to pass through there. That is going to give us that, and then both of these are going to go into an AND gate, a very large AND gate, don't worry about it. And then these two values from the NOR gate here and the AND gate here are going to go into yet another AND gate, and that is going to give us the unsimplified version using whatever gates we need. Step 2 of this process is going to be to recreate this circuit using only NAND gates. So in order to do that, we're going to be replacing all of these individual gates. So the first one we're going to be replacing is this NAND gate right at the front, which is pretty easy, because all we're going to do is turn that into a NAND gate and then add an OR gate directly on top of it. It's a little cramped there, but you can see how it works. Then this AND gate is actually going to do the exact same thing. So we're going to replace the AND with a NAND, then add another NOT. That's going to connect that. The OR gate is just a little bit more complicated than that, but overall still not bad. All we're going to do is add another OR gate, or a NOT gate, to the front of both of these. And that, after turning this into a NAND gate, will give us the same output. The truly difficult one is going to be the NOR gate. So this one's actually going to require a decent amount of rewriting. So, in order to do this, we first want to take both of our values and put them with themselves through a NAND gate. So, we're going to write it like that. And then, we're going to take both of these values, put them through a NAND gate together, and then one more time we're going to take this and then put it through a NAND gate with itself, and that will convert all of it into only NAND gates. Step 3 of this process is going to be to remove the double NOTs. Fortunately, this only has one instance of double NOT that needs to be removed, and that is going to be this right here. So we're going to erase those two NOTs and just replace them with a straight wire. Everything else is fine, which allows us to move on to step 4. The final step to this is to replace these NAND gates with the appropriate dual symbols if needed. Just like with step 3, there's only going to be one example of one that needs to be switched, and that is going to be this one right here. The reason why this needs to be switched is because there is a bubble for one of the inputs in the form of y prime, but nothing in the form of x. So, in order to fix that, we are going to erase this NAND gate and replace it with an inverted OR gate, which is going to look a little bit like this. All of the other gates actually work perfectly fine here. So with that, we have officially simplified this to using only NAND gates for the circuit of the unsimplified Boolean equation.